In this episode of Sea Power, we investigate the various types of missiles that a modern vessel may carry. Today, the missile reigns supreme. There is a missile for every situation, from shoulder-launched to the fully blown intercontinental nuclear ballistic array of weapons. Today, no country would go to war without a substantial inventory of these most deadly and accurate armaments. At sea, the missile has become a most adaptable weapon platform to launch an attack or to instigate anti-attack measures. One of the deadliest missiles is the US Navy's Harpoon series of projectiles, the RGM-84A. The Harpoon is like a mini aircraft, as it is propelled by a powerful turbojet engine. It is fired from a canister or tube launcher. This missile was designed and built by McDonnell Douglas for the US Navy, and it was to have over-the-horizon capability and have all-weather ability. This version of the Harpoon has a range of 50 nautical miles. The Harpoon is a flexible weapon, and it can be fired from ships or submarines. The aircraft version is the AGM-84. Once launched, the missile descends and skims the wave tops. As it nears the target, the active search radar is initialized. It has waypoint ability and it can approach its target from any angle. In a combined attack, two missiles can approach the target from completely different angles. Harpoon can also navigate around landmass to acquire its target. Once locked on, the Harpoon missile can deliver its warhead by using the pop-up maneuver. In the final approach, the missile climbs sharply and approaches the target from directly overhead. It can also determine evasive action for anti-missile warfare, and that makes the Harpoon one very smart weapon. The missile is used on a wide variety of naval vessels, from the larger battleships down to the smaller patrol ships. And more than 15 navies throughout the world use it. The French equivalent of the American Harpoon is the French Exocet missile and is built by Eurospatial. This rocket-driven missile proved its worth for Argentina in the Falklands campaign, as it crippled or destroyed various British ships. It can be fired by aircraft, ship or submarine, and has a range of more than 26 miles. When launched, the missile will curve to attain the target and descends to near sea level. It is kept on course by its internal guidance platform and radar alternator. The ADAC adaptive radar commences operation when the Exocet comes within 6 miles of its target. The ADAC sweeps the area and acquires the target, steering the missile to impact with the target at optimum height above the waterline. The SM-39 is the submarine variant. The Exocet is launched with special containers from the submarine's torpedo tubes. The AM-39 is the air-launched type. Over 100 Exocets were fired by Iraq during the Gulf War. Most versions of this missile have a Hexal light and steel block warhead and are designed to detonate after penetrating the hull of the target. These are some examples of the Exocet hit. Sea Dart is a surface-to-air missile system mounted on air defence destroyers of the Royal Navy. The weapon is powered by a combination of solid-fuel booster rocket, which is used for launching the missile, and simple ramjet, which gives it a speed of Mach 2. The missile is effective over a range of approximately 80 kilometres. Sea Dart entered service in 1967 on HMS Bristol, before becoming widespread on the Type 42 destroyers. The Sea Dart-equipped Type 42s are reaching the end of their service lives. The much more capable PAMS missile system will replace the Type 42 from 2007. The standard British air defence missile, the Sea Dart, is a semi-actively homing ramjet. The Sea Dart is credited with 7 aircraft shot down during the Falklands War. This is Royal Navy frigate Broadsword, and she's equipped with the Exocet missile for offensive action and Sea Wolf missiles for defence. Current deployment is on Type 22 and Type 23 frigates, the newer ships taking 32 missile silos. It is expected to remain in service until 2020. The Sea Wolf is a naval anti-missile missile and is designed as a final line of missile defence against both sea skimming and high-angle anti-ship missiles. It can also operate against aircraft. It has been used by the Royal Navy since 1979 and has been fired in anger during the Falklands War and the Persian Gulf conflicts. The manufacturers claim the missile can intercept targets as small as 114mm shells. BAC developed the system from a 1964 requirement. A contract was awarded in 1967 to BAC, Vickers and Bristol Aerojet. Testing lasted from 1970 until 1977. The Aegis combat system, named for the mythological Aegis shield, is a United States Navy weapons system. The first cruiser of this class was the Ticonderoga. This is not just a missile, it is a complete system, and was first tested on the Phantom, the 34 Firebee and the Sabre. This is the chief offensive and defensive missile of US Navy fleet, and will remain so approximately until the year 2010. It can be used to destroy aircraft, cruise missiles and missile launch platforms. The computer-based command and decision element is the core of the Aegis combat system. This interface makes the Aegis combat system capable of simultaneous operation against a multi-mission threat: anti-air, anti-surface and anti-submarine warfare. The Navy built the first Aegis-equipped destroyers using the hull and machinery designs of Spruance-class destroyers. The heart of the system is an advanced automatic detect and track, multi-function, three-dimensional phased array radar. Known as the shield of the fleet, this high-powered radar is able to perform search, track and missile guidance functions simultaneously, with a track capacity of over 200 targets at more than 200 miles. Because the Aegis system dominates the ship architecture, ships equipped with it are sometimes mistakenly called Aegis-class ships. The early version was the Mark 26 dual-purpose launcher. This is the Mark 41 version, and 54 of these are fitted to the ships in environmentally sealed canisters. A key element of the system is the radar. Once fired, the missile will immediately turn towards its target.
Positive identified as 1 Alpha uniform.
The radars generate an enormous amount of information regarding so many targets and produce instant solutions. The Aegis-equipped vessels are probably the first vessels in history that cannot be swamped by incoming threats. In fact, nobody has yet been able to determine just how many targets Aegis system can track simultaneously.
Man battle stations missile. Man battle stations missile, aye, sir.
Perhaps one of the deadliest missiles ever built is launched from under the sea. This is a ballistic missile submarine. These submarines were first deployed by the US Navy during 1960 and were armed with the Polaris intercontinental missile, and later the Poseidon. The latest version of this type of weapon is the Trident. The Trident missile is an intercontinental ballistic missile, or ICBM, and is armed with nuclear warheads. The Trident was built in 2 variants, the one C4 UGM-93A and 2 D5 UGM-133A. The C4 and D5 designations put the missiles within the family that started in 1960 with Polaris A1, A2 and A3, and continued with the 1971 Poseidon C3. Ideally, the missile is sheathed in gas bubbles for its entire time in the water, so liquid never touches its fuselage. The launch from the submarine occurs below the ocean surface. The missiles are ejected from their tubes by gas pressure created by a gas generator, a solid fuel rocket motor attached to the bottom of the missile tube and exhausting into it. Both Trident versions are 3-stage solid propellant inertially guided missiles, whose range is increased by an aerospike, a telescoping outward extension that halves frontal drag. After the missile leaves the tube and rises through the water over the submarine, the first stage motor ignites, the aerospike extends, and the boost stage begins. The Trident is carried by 14 active US Ohio-class submarines and 4 UK Vanguard-class submarines. The Tomahawk land attack missile is a long-range, all-weather subsonic cruise missile with stubby wings. Introduced by General Dynamics in the 1970s, it was designed as a medium to long-range, low-altitude missile that could be launched from a submerged submarine. It has been improved several times and is now made by Raytheon. There have been several variants employing several kinds of warheads. The operational versions include the unitary conventional land attack, TLAM-C, the bomblet dispensing land attack, TLAM-D, and the nuclear land attack, TLAM-A and TLAM-N. There is also the Tomahawk anti-ship missile, TASM. By far the biggest improvement is making the Tomahawk network-centric warfare capable, using data from its multiple sensors, such as aircraft, satellites, foot soldiers, tanks and ships to find its target. The tactical Tomahawk can be reprogrammed in flight to attack one of 16 pre-designated targets, with GPS coordinates stored in its memory or to any other GPS coordinates. Also, the missile can send data about its status back to the commander. It entered service with the Navy in late 2004. Tomahawks are difficult to intercept due to their small size, small radar cross-section and low altitude flight. The missile is launched and steered for the first few seconds of flight by a solid fuel booster with steering vanes in its exhaust. Then the stubby wings and control surfaces are deployed and the turbofan engine takes over. Over water, the Tomahawk uses inertial guidance to follow a preset course. Once over land, terrain contour matching aids the inertial system. Terminal guidance is provided by the digital scene matching area correlation system, producing a claimed accuracy of about 10 metres. The Kosovo War in 1999 saw HMS Splendid become the first British submarine to fire the Tomahawk in anger. The Royal Navy later used them in the 2001 Afghanistan War and Operation Telic, the British contribution to the 2003 Iraq War. The Tomcat was the first fighter to have the remarkable Phoenix missile system. The test operation was called 6 on 6. If the test was successful, the system would prove to be a quantum leap in fighter ability. The objective of the test for the Tomcat's pilot was to attack and down 6 targets simultaneously. The targets included 2 drones that flew at supersonic speed, 3 training aircraft which simulated slower moving targets such as bombers, and another ground-launched drone to imitate a supersonic missile. On the radar, the 6 targets were identified and designated a prefix. From that point on, the pilot just pressed the firing button as the targets became locked on.
One's away. 2's in the air. 3's in the air. 4's in the air. Check the target cameras.
4th missile in the air.
At one time, all 6 missiles were in the air tracking their targets. This was due to the 50-mile range of the Phoenix.
6 in the air.
It was determined, after retrieving the test data, there were some slight modifications. The Tomcat Phoenix combination would, under combat conditions, give the pilot an 80% hit rate. Firing missiles from planes has always had problems. One of the major problems is the performance of the plane's jet engines when they are caught in the hot exhaust gas of the released missile. Temperature gradients of up to 6,000 degrees Celsius a second can be realised when a missile is fired from an aircraft, and this can severely hamper the aircraft's jets. This is a Eurofighter. When a Eurofighter climbs into the sky, it takes a load of high technology aloft. Its 2 EJ200 engines give the strike aircraft breathtaking agility and speed. EJ200s are totally reliable, even when they're caught in the hot exhaust jet of a missile just fired. In a first for a European company, MTU Aero Engines has managed to simulate that situation on the ground, which saves customers much money. MTU's engineers have conceived an innovative test setup to simulate the temperature profiles and gradients involved in missile firing. At the heart of the test arrangement was a specially fabricated hydrogen burner installed in the front of the intake of an EJ200 production engine at a Munich test stand. The results of over 100 test units witnessed that the EJ200 proved superbly stable and tolerant of the exhaust gas temperature profiles of rocket engines. An impinging hot exhaust jet puts engines under formidable stress. The searing temperatures may cause an abrupt compressor stall, with the air no longer passing through the engine but being forced in the opposite direction, and the notorious engine surge condition occurs. If the condition is bad enough, a blowout in the combustor results and the engine dies. If it doesn't recover, the pilot has to try and relight it. Previous tests were done in the air. Now they can be simulated in safety and in controlled conditions on the ground. The Eurofighter is the first aircraft to have such an evaluation on its performance while firing missiles, and this has saved the military millions of dollars. That concludes this episode of Sea Power. Join us again when we continue our fascinating journey of discovery of sea power.